All right, so we just went over our vocab on perpendicular bisectors and angle bisectors. So we're going to focus on the perpendicular bisector again, or not again, now for the first time. So the vocab, this is very helpful. If we can remember, perpendicular means we have right angles. Bisector means we bisect or cut into two congruent or equal parts. So we're going to have a right angle and we're going to have two congruent segments in this case. All right, so part A, given that line DA is the perpendicular bisector of BC. So when it's phrased like this, that means that segment BC is bisected. So this segment is getting cut in half. And then where these two meet, where DA and BC meet, we're going to have a right angle. So let's fill in that information to the picture. We know that DA is, so here's DA is a perpendicular bisector of BC. So we actually already have the right angle filled in. That right there is the perpendicular part of the perpendicular bisector. And then the bisector means we're going to bisect or cut BC into two congruent parts. So BC, here's BC, where this hits, this segment BD will be congruent to this segment DC. So let's just go ahead and mark the congruency in our picture. All right, so because DC we're told is 16 units long, that tells us that BD also will be 16 units long. So just based off the picture and the fact that we were given a perpendicular bisector, we can come up with all of that information so far. So now what's the question? I didn't even look at what they were asking. What is the length of BD? Oh, well, we just figured out that BD is equal to 16. Because we knew that DC was 16 and BD and DC would be congruent because of the bisector part of this definition, they both would be 16. All right, part B, given that line L, right here, is the perpendicular bisector, and they didn't say of DE, but it is the perpendicular bisector of DE. So when we see that we have a perpendicular bisector, let's go ahead and mark our right angle. Oh, the right angle is already marked. And then let's go ahead and mark the congruent segment. So DE is getting bisected. That means that DF will be congruent to EF. All right, now what else did they tell us? They said if DE is equal to 10, so we're told that this whole segment right here is 10. What is DF? Well, if this larger segment just got bisected, meaning cut in half, into two congruent segments, all we have to do is take the total length 10 and cut it in half. And we get 5. So we know that DF is 5 and EF is 5. So what is DF? DF equals 5. All right, part C. Given that line L is the perpendicular bisector of DE again, I feel like they could have added that part. So perpendicular bisector, let's put in our right angle. Again, they already have the right angle, but we are bisecting DE. So let's go ahead and put in our congruency marks. Maybe I'll use 2 congruency marks this time. It doesn't matter how many little marks or ticks you put on the line as long as they're matching. Anyone that walked in and said, "Hey, what you looking at?" Oh, I can see these two segments are congruent because they have the same marks on them. Okay, now we're told that DF is equal to 2x plus 9. So DF is just from here to here. This is 2x plus 9. So I'm just going to write that kind of small, 2x plus 9. And FE is 5x minus 18. So FE in the picture is this part of the segment. That is 5x minus 18. Find x. And then after we find x, we're also going to find the length of DE. All right, so when you guys have geometry problems, it's very, very common that you have to set some things equal to each other. You might add two things together to equal a total number or a total length. And so we have to kind of decide based on the information we know, would we set these two equal to each other, or could we say that 2x plus 9 plus 5x minus 18 equals the whole segment? Well, if we knew how long DE was, the whole thing, then yeah, we could say 2x plus 9 plus 5x minus 18 equals, let's say, 70. But they didn't give us that information because we don't know how long the whole segment is. But we do know that these two segments are congruent. Anything that's congruent, you can set equal to each other. So we're going to say 2x plus 9 equals 5x minus 18. We're going to solve this equation. All right, so when solving the equation, let me please give you helpful hints. Do you notice how we have x's on both sides of the equation? I want your very first step to be getting those x's to the same side. I don't want you to worry about these numbers. I see so many students take a wrong turn in solving equations when they do not get your variable to the same side first. So to do that, we could subtract the 2x or subtract the 5x. I think I'll subtract the 2x. That just leaves us with positive x's on the right side of our equation. 2x minus 2x is 0, so we get to cross that off. I'm going to carry down the 9 equals 5x minus 2x is 3x, and I'm going to carry down the minus 18. All right, now we're looking at a two-step equation. To solve for the x that is connected to the 3 right here with multiplication, that dividing by 3 is our last step, which means we need to take care of the minus 18 first. The opposite of subtracting 18 is adding 18 to both sides. 9 plus 18 is 27 equals, I'm going to carry down the 3x. Divide by 3 to get x equals 9. So that answers one thing they're looking for, find x. Now when it says find the length of DE, what that means is we just take our value of x and we can actually plug it in. We have some x's here. So maybe it doesn't matter which one you plug it into. Maybe I'll plug it into this one. 2 times x plus 9. So I'm going to replace the x with a 9 now that we know what it is. 2 times 9 is 18. 18 plus 9 is 27. So DF is 27. Now I could plug the 9 in here as well and then add those two segments together to get DE. Or we might recognize or remember, oh yeah, these segments are congruent. So if DF is 27, then FE is also 27, which means that DE will be equal to 27 plus 27 to get the total length. And 27 plus 27 is 54.